the alternating series test. We will use that on this because this is an alternating series. Now the directions said to write the first 4 terms, so let's just start with that. Term number 1 is what happens when I plug in a 1, and I'm going to have 1 over negative 3 to the 1 minus 1. Negative 3 to the 0 is 1. That gives me 1 over 1, which is 1. I don't want to write it again. Next term. We are going to plug in a 2. I plug in a 2. I'm going to have 2 over, I'm holding off on my signs here. 2 minus 1 is going to give me 1. Negative 3 to the 1 is going to give me negative 3. All right? Going to keep cranking out these terms as the sunlight creeps in over here in the corner of the board. And I'm going to plug in a 3. 3 over, by the way, because this is an alternating series, I keep doing my hand like this, the signs are switching back and forth. Positive, negative, positive. And it has everything to do with this negative 3 that is continually being raised to consecutive powers, and when it's raised to an odd power, it's negative. When it's raised to an even power, it's positive. Okay, anyway, plug in a 3, you'd square a negative 3. That would give you a 9. Yes, that one reduces. I'm not feeling like it right now, so let's not. We're all adults here. We can leave it like 3 over 9 if we like. The next one I know is negative. Plug in a 4. I'll have a 4 there. And here I will have 4 minus 1, which would give me 3. Negative 3 to the 3 is a negative 27. Those are my first 4 terms. This does keep going, so to say this equals this is wrong, because it does keep going. Okay, but now let's find out if this alternating series converges or diverges. And if it's going to converge, then it needs to meet 2 criteria. Criteria number 1 is it has to pass the nth term test, but it has to pass the nth term test for its absolute value. Okay, so I am not going to treat it like this. I'm going to treat it like the whole thing is positive. We'll hold that thought. But I'm going to write my 2 criteria over here. They're on your notes. But the limit as n approaches infinity of a sub n is equal to 0. Let's absolute value that. It may not be that way on your notes, but I'm going to do that just for the sake of conversation, even though it's a one-way conversation because it's a video. And also, any next term should be less than or equal to, actually just less than, the one before it. Less than the one before it. Okay, make sure it's not equal to. Yeah, it could be equal to. Okay, yeah, let's fix that. There we go. Had a little bit of a brain flatulence there. Okay, so we are going to, well, generate first 4 terms, done. Talk about the alternating series test. These are the criteria. And we're going to also treat this like every term is positive. Well, how do we do that? Well, if I were to rewrite this, and I feel like it, if I were to rewrite this as if every term was positive, then I wouldn't have a negative 3 down here. I wouldn't. It would be positive 3, because that was the problem. The problem was that 3 was negative, and so as I continued to raise it to a power, it was positive, negative, positive, negative. So this is what I'm really dealing with. Now, to say that this is equivalent to that is wrong, because I also do have that toggle factor. It's what I'd multiply by every time, which was the negative 3, but I do need the 3 because it has some magnitude to it. So let's actually factor out a negative 1, and that'll be an n minus 1 there. And negative 1 to the n minus 1 times 3 to the n minus 1 is negative 3 to the n minus 1. So we've taken care of that here. So as I deal with this, my explicit form that I'm dealing with is really this guy right here. That is a sub n, okay? There is a toggle factor that swaps that back and forth. So just for the sake of what we've been doing, I'm going to treat that like it's not absolute valued, because taking out the toggle factor doesn't mean my signs are going back and forth anymore, and it's just straight up positive, so I don't need the absolute value. I put it in there just for the demonstration of what's about to happen. So here we go. We're going to test our we're going to use the alternating series test, which involves those 2 tests right there. And so here's test number 1. The limit as n approaches infinity of a sub n, which was this, so n over 3 to the n minus 1, is equal to, okay, use your knowledge of magnitudes. Numerator is linear, denominator is exponential with a little twist to it. If you want to, and you could treat it like n over 3 to the n times 3 to the negative 1, which is really 3n over 3 to the n. Totally fine. You can do it that way if you like. Either way, you're going to have linear divided by exponential. Linear divided by exponential, as you approach infinity, the denominator overpowers the numerator. Denominator gets really big, numerator doesn't get big nearly as fast, and therefore we have just passed the nth term test. Mission accomplished so far. There we go. All right, is the next term consistently less than or equal to, equal to was important, left it out earlier, less than or equal to the current term? Let's find out. So I'm going to use this form of it. You can use this if you like, but I'm going to use this form of it. And as I do, I'm going to have 3 times n plus 1 over 3 to the n plus 1. Every n becomes n plus 1. That's what I have. And it should be consistently less than or equal to the current term, which is 3 to the n over 3n over 3 to the n. 3n over 3 to the n. Okay, so we're going to manipulate this and make sure it's a true statement. If it's false, then we'll say, nope, doesn't converge. If it does, we'll say this alternating series converges because we have met criteria number 1 and then potentially criteria number 2. So let's keep moving. Let's 3n plus 3 numerator, 3n times 3 denominator, 3n over 3 to the n. I called that 3n, it's 3 to the n, I bet. I believe we can multiply everything by 3 to the n, and it would cancel those. And I would have 3n plus 3 over 3, which would be, whoops, I put equal here. That should be less than or equal to, less than or equal to 3n. And then we'll just keep going with this thing. We can divide everything by 3 on the left, and that'll give me n plus 1 is less than or equal to 3n. And if you're like, well, I don't know if that's true or not. Well, let's think about the n values we're using. What n values am I using? From the very beginning, it starts at 1, it goes to infinity. Well, let's just keep going with this idea. Bring this up here. If I subtracted n from both sides, I'd have 1 less than or equal to 2n, which means n is greater than or equal to 1/2. I read that backwards as I wrote it backwards. Let's write it one more time. There's that. Question. N is greater than or equal to half. Is that true? Yeah, always, because I start at 1, so of course it's greater than or equal to half. So, mission accomplished, mission accomplished. The series converges. The series, the alternating series converges. Now, later we'll get into convergence, absolute convergence, conditional convergence. We're not going to mess with that right now.